Hi students, let us pass on to another experiment conducted by Mendel, that is dihybrid cross. What is dihybrid cross? The inheritance of two contrasting pairs of characters. The inheritance of two contrasting pairs of characters. Now, it is a cross involving the inheritance of two contrasting pairs of characters at the same time. So we are focusing on two different characters in a plan. We are not separating the characters, we are not isolating the characters, we are studying the inheritance of two characters together. He took two characters, one, the shape of the seed, and in the shape of the seed there are two varieties or two forms, one round, another one wrinkle. So these two are contrasting characters. Another character he took, that is the color of the cotyledon. And this also, there are two varieties. One yellow, another one green. So he took two characters, one the shape of the seed, and which there are two different varieties or contrasting characters. One is round, another one is wrinkle. Another character he took, color of the cotyledon, two varieties, yellow and green. He concentrated on two pairs of characters, that is round yellow and wrinkle and green. So round, wrinkle, contrasting characters, yellow and green. He wanted to know which character was round. For that he conducted monohybrid cross. For that he took round and wrinkle varieties, he crossed and found that round variety was dominant over wrinkle. So the gene for round is dominant over wrinkle. That is, R is the dominant gene and small r is the recessive gene. Similarly, he conducted monohybrid cross. Want to know the nature of the dominant character with reference to the color of the cotyledon. He took two plants, one with yellow, another one with green. He crossed, he obtained yellow. He found that yellow character is dominant over the green. So first he conducted the monohybrid processes and found which was the dominant character and which was the recessive character. Now he studied two characters together. He followed the inheritance of two different pairs of characters together. He took one plant with round yellow, round seed with yellow. Both are dominant characters. He took another plant, just it produced seeds. The seeds are wrinkled and green. So uneven actually shape, the color of the cotyledon green. So this is what he took for his experimental analysis. He wanted to know how far these two characters are inherited simultaneously. Now the genotype, you see that one, this is a genotype of round yellow dominant variety. And this is a genotype of a recessive variety. So this is called double dominant because we have two dominant characters. And this is called double recessive because we have two recessive characters. He crossed these two plants, dusting the pollen grains from one on the stigma of another. All the effort individuals he obtained was actually were around yellow. All the individuals obtained actually, that is in the effort generation, were around yellow. That is, as round is dominant over actually wrinkle, the round varieties, actually round character is expressed. As yellow character is dominant over green, the yellow character is expressed. The individual obtained this F1 generation is called dihybrid. The meaning for that one, an individual differing in two different pairs of factors or traits. So the phenotype around yellow. Now this is also the cross pollination. Cross pollination between round yellow and wrinkle green. Now he took that is the F1 individuals. He crossed. This is called actually self pollination. He crossed two F1 varieties having the same genotype and having the same phenotype. So both are round yellow for both the characters. Both are round yellow but heterozygous. They are not pure breeding varieties. The parents which you have taken for the cross, they are all the pure breeding varieties because the genes for a character are similar or otherwise called homozygous. But here the genes for a particular pair of characters. See here, round is heterozygous and yellow is heterozygous. That's why they are called as heterozygous individuals and are also called hybrid or dihybrid, differing in two pairs of factors. Now, what are the gametes produced by these individuals at the time of gamete formation? Now, according to Mendel was success. Mendel was success because the genes for different characters are located on different chromosomes, not in the same chromosome. So, according to him, the gene for round shape or shape of the seed, simply we can say the shape of the seed located in one chromosome, one particular chromosome. Suppose I am taking this is a seed with the round shape. This is a common one, homozygous. But here, a heterozygous condition, I am taking the gene for round is located, let's assume in the first pair of chromosomes, the gene for round or the gene for shape of the seed. Now the gene for the color of the cotyledon is an example of just yellow, there is a green gene. These are the genes located maybe in another pair of chromosomes. So one of the reasons for Mendel's success was the genes for different characters are located in different chromosomes. That's why normally we have the formation of different types of gametes. So what are the different types of gametes produced when the genes for different characters are located on different chromosomes? Now I am taking here. Now the nature of the genotype you are taking just capital R small or capital Y small. If you are analyzing the chromosomes, maybe I mentioned one, that is capital R small r. These two are a pair of chromosomes, the homologous chromosomes. I am taking, that is what we call capital Y small y. This is another pair of chromosomes. So this is the nature of the individual having all genes in one pair of chromosomes and Y genes in another pair of chromosomes. That's the reason why Mendel was success in his experiment. Now during the gamete formation, what will happen? This R gene may combine with, that's what's called capital Y, forming one gamete. This is what's the random union, also called as independent assortment. So the R may combine with capital Y or small y. So it may combine with capital Y, so forming this is one type of gamete. It may also combine with what is called a small y, forming another gamete. This is what's called random combination. This is called independent assortment. So during gamete formation, the genes or the factors assort independently of one another as they are present on different chromosomes. So R may combine with capital Y or small y. Likewise, the small r may combine with capital Y, or it may combine with what is called small y. This is the meaning. But in modern theory, the gametes are formed because of crossing over. But according to Mendel, the gametes are formed because of independent assortment, because the genes are located in different chromosomes. They can combine with anybody at the time of gamete formation. So this is the way I am telling that one what's called independent assortment, one of the laws of Mendel. I'll tell you later about this one. So the genes present on different chromosomes may combine with one another independently of one another, resulting in the formation of 4 different types of gametes. So if an individual is differing in 2 pairs of characters or traits or what we call the factors or genes, the number of gametes produced by the individual is normally 4. See, in the case of monohybrid cross, we have actually the individual, the heterozygous individual, capital T small. This is a heterozygous individual. So we have differing only one pair of genes. If the individual is differing in only one pair of genes, then the resultant gametes are 2 in number, one with capital T and one small. So the number of gametes produced actually is equal to the number of contrasting factors. The number of gametes produced in monohybrid cross is 2. The number of gametes produced in dihybrid cross is equal to 4. The number of gametes produced in trihybrid cross is equal to 8. The number of gametes produced in tetrahybrid cross is equal to 16. That means the number of gametes is increasing geometrically 2, 4, 8, 16 like that, according to the nature of the individual, either monohybrid or dihybrid or trihybrid or tetrahybrid. So we don't want such things. Now for easy remembrance of formation of gametes. So this is actually happening. Genes present different chromosomes combine and recombine in different way to form 4 different types of gametes. But for examination point of view, you can remember how far these gametes are produced in a shortcut method to remember how far these gametes are produced. So I am taking for example capital A, small a, capital B, small a. This is a dihybrid. I am taking different letters. Want to know the formation of gametes? I explained the mechanism of gamete formation already. So I want to discuss one more with some other letters. Now this is a dihybrid, differing 2 pairs of factors, dihybrid. Now the genes for different characters or traits are located on different chromosomes. For example, this is maybe the first chromosome, maybe the second chromosome. Here you see the genes are located in different homologous chromosomes. So as a result, this A may combine with capital B at the time of gamete formation, that is called independent assortment, to form one gamete. This is one gamete. And it may also combine with what is called this chromosome to form another gamete. Likewise, the recessive gene may combine with what is called the dominant gene present in another chromosome to form what is called this variety. Or we can have this may combine with this small b to form this. So this is called independent assortment. The factors are formed remain independent in different chromosomes. So they may combine with anybody at the time of gamete formation, resulting in the formation of 4 different types of gametes. When an individual is differing 2 pairs of genes, we have received 4 different types of gametes. Now, how to remember? This is the mechanism. Then how to remember the formation of gametes? The same letter I am taking, then comparing with this one. So this is a dihybrid. Take the first 2 letters. Write twice each, separately. Then take the next 2 letters. Add these 2 letters alternately. So we are getting 4 gametes. This is for easy remembrance. This is for easy remembrance. So, a dihybrid produces 4 types of gametes because of random union, as the genes are located in different chromosomes. This is for examination point of view. Remember that one in your mind in a shortcut method. Similarly here, see I mentioned 4 different types of gametes produced by this F1 generation individuals. So I am taking the first 2 letters, that is capital or small. Writing each one twice. I am taking the next 2 letters, adding each one alternately. Capital Y, small y, capital Y, small. So these are the 4 different types of gametes produced. This is the way we can remember easily how far the gametes are formed. The mechanism is different. This is the way we can remember while writing in the examination. Hi students, here is a Punnett square board or checkerboard to just show the possible probability of genotypes in the offspring of F2. That's the main aim of this checkerboard. As we have 4 different types of gametes produced either by male or female, the possible probability of 16 individuals, though in field we have different number, but we are making that one in a short way of what is called the ratio. For that we are reducing the numbers of individuals into perfect ratio. So as we have 4 male gametes and 4 female gametes, 4 male gametes and 4 female gametes, we have the probables are 16. 4 into 4, 16. Now, this is a male gamete. I am writing just horizontally the male gametes, then, sorry, I made a mistake. I am writing vertically the male gametes and horizontally the female gametes. Now, this male gamete may have the chance of fertilizing this one. So this is a simple multiplication. And this one also have the chance of fertilizing another one. This one like this. And also. So I am taking the box number 1, 2, 3, 4 for understanding. So this gamete has a chance of actually fertilizing this one, that one, that one. This is called random union, not at the same time at different times. We are finding out only the probability. Now if we are taking the genotype here, all dominant factors. Here we have just 3 dominant factors. Here also we have 3 dominant factors. Here also we have 2 dominant factors. For remembrance, the first one we have 4 dominant factors, the second one 3, the third one also 3, the last one, the fourth box, has 2 dominant factors. Now, instead of just writing all these things together, if you know the genotype in these 4 boxes, they will be repeated. Now, what you have in the second box here, what you have the third box here, what you have the fourth box here. So I am writing the same one, capital R, that is capital Y, small y, the same one. Here the third one, capital R, small r, this one. I am writing the fourth one as here, 2 dominant letters. Okay, this is one way of remembering. Now, I mentioned about, as a result of this random union, we have received 16 individuals. Out of 16 individuals, 9 individuals are round yellow. Where are they found? So this is round yellow, this is round yellow, this is round yellow, this is round yellow. And this is round yellow, this is round yellow. And this is also round yellow. So here 1, 2, 3, 4, 5, 6, 7. Where are the remaining 2? The remaining 2 are present in the diagonal line. Here capital R, small r, capital Y, small r. Here capital R, small r, capital Y, small r. See, these 9 individuals which are found actually in a triangle, they represent what is called the round yellow phenotype. So 9 round yellow you can have in the box. So horizontally 4, vertically just we have 4. In what we have in the diagonal line, the same genotype. Here, 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 here. So one genotype is of this type. 2 of these are one genotype. 2 of these are one genotype. These 4 are one genotype. Even if you want to make what is called genotypic ratio. So 9 round yellow. Now let's go for the next one. I am taking this one. Taking the next gamete, filling the next. Now this may combine with this. See the box I am filling, and it may also combine with this one. And I am taking actually, see, in these cases. Now here also I am taking that one. That is, this one may also combine with this. Okay, so these are the 3 individuals. So this is round green, round green, round green. So 3 individuals are round green. So you can fill up these, the gaps. They also form, you see that one in apparent triangle. These 3 are formed in the apparent triangle. Non-continuously, apparently, you can make the triangle. These 3 are regular yellow. Now, what about actually the remaining? So, we have what's called wrinkled yellow 3. I am taking this one and crossing, right? You see that one, this one, here, another one, here, another one. So, This small triangle represent what is called, we see that one wrinkled yellow. See, the recessive gene for wrinkle is present, one dominant gene is present, here also one dominant gene is present. So wrinkled character can be expressed only in recessive homozygous condition, whereas the dominant character can be expressed in what is called even in heterozygous condition. That's why we are getting what is called wrinkled yellow. Then the last one, we see the wrinkled green. We are making that one having two pairs of recessive genes. And this one is separate. What I meant circling is separate. So you can find, so 9 individuals in the big triangle represents round yellow, and these 3 represent the round green, as they have at least one dominant gene, the remaining 2 are recessive genes. And here we have 2 recessive genes, at least one dominant gene, so that we have wrinkled yellow, and here 2 pairs of recessive genes. Hence we have what is called actually green with the wrinkled seeds. So this is the one what we have obtained. 9 round yellow, just round green 3, wrinkled yellow 3, wrinkled green 1. So these are all the results obtained. So as the result is that one, 9 individuals are formed with the 2 dominant genes, or 2 dominant traits, or with the 2 dominant factors. You see, one dominant factor, another dominant. So 9 individuals with 2 dominant factors or 2 dominant genes. Then 3 individuals actually they have one dominant gene, at least one recessive gene. So dominant gene, recessive gene, dominant gene, recessive gene, dominant gene, recessive gene. And another 3, they also have actually at least one recessive gene, one dominant gene. So recessive gene, dominant gene. So 9 individuals with actually 2 dominant genes. 3 individuals have one dominant gene, one recessive gene or factor. Another group of individuals, what I mentioned, wrinkled yellow 3, they too have one recessive gene, at least one recessive gene, one dominant gene. The last one, wrinkled green, has 2 pairs of recessive genes. So you can remember this one in this way, a big triangle representing the 9 individuals. These 3 discontinuously present show one character. Another one found continuously, that is formed actually a small triangle, a wrinkled yellow character, and finally only one represented at the corner, and that is wrinkled green. Now you have these 2 varieties. So these 2 varieties, that is the 2 dominant genes and here 2 recessive genes. These 2 varieties are the round yellow and wrinkled green, considered as the parental combinations. We started the experiment with the round yellow and wrinkled green. So that we are getting what is called the parental combinations 9 round yellow and 1 what is called wrinkled yellow. Totally 10 individuals out of 16 are considered as the parental combinations because they are looking like the parent what we started with the experiment. I will show that now. So out of 16, 9 round yellow, 1 that is wrinkled green, genotypic ratio, wrinkled green. So these are the 2 varieties what we started for the experiment. So totally 10 individuals represent the parental combinations. Parental combination. Because they are resembling the parental combinations. Out of 16, 10 are resembling the parents what we started with the experiment, hence called parental combinations. The remaining 6, for example, round green, 3 round green, 3 wrinkled yellow. So totally 6. These individuals are called recombinations. New combinations. So out of 16, 10 are resembling the parents, hence called the parental combinations. The remaining 6, because of recombination, we are getting actually different varieties, new varieties, round green instead of round yellow, wrinkled green, so wrinkled yellow instead of wrinkled green. These 6 are all recombinations. So if you take the ratio of parental and then recombinations, we have 10 is to 6, or we are reducing that one 5 is to 3. So out of 16, 10 are parental combinations, 6 are new combinations or recombinations, or we can reduce the ratio into 5 is to 3. This is another thing. So this is all what we have actually received as per the diabetic class. Now, Mendel concluded that the factor for each trait remain independent. The factor for each trait remain independent and maintain stability in the gametes. As these factors are independent to one another, they pass on to the next generation through the gametes. The factors remain independent to each other as present on different chromosomes. They are inherited to their offspring through the gametes during the process of fertilization. Based on the results obtained, Mendel proposed certain principles in the form of laws. These laws are called Mendel's laws of heredity. So in the syllabus given 3 laws, 1 law of dominance. So when 2 homozygous individuals which are pure for contrasting characters, for example Tall and Dwarf, these 2 are actually homozygous individuals for contrasting characters across. Only one of the characters expresses itself in the F1 generation, what is called the tau. So this is P1, homozygous individuals, Q for contrasting characters. When crossed, only one of the 2 characters expresses itself with the F1 generation. That character is called as the dominant character and the gene is called dominant factor. The other character which is being masked or suppressed is called as a recessive character, and this is called law of dominance. We already discussed. This is based on the monohybrid class. Let's go for law of segregation. Now in the case of law of segregation, if you are taking F1 generation, we have heterozygous condition. So when a pair of alleles, that is what's called the contrasting alleles, are brought together in F1 generation. See, the 2 alleles capital T and small t are brought together in F1 generation. Suppose for example, this is F1 generation present in chromosomes. They remain together without mixing, without blending. During gamete formation, the 2 genes get separated and enter into each gamete. So each gamete contains only one of the 2 genes, either capital T or small t. So the meaning for them, there is no mixing, there is no blending. So how can you know that there is no mixing or blending? The appearance of dwarf character once again during F2 generation. See, in the F2 generation we are getting both tall and dwarf. In the F1 generation there is no appearance of dwarf character, but the reappearance of dwarf character in the F2 generation indicated that the 2 genes of a heterozygous individual or a hybrid remain together without mixing. So these 2 are acting as different units or separate entities. They separate, the meaning for segregation separate. They separate and enter into each gamete so that each gamete receives only one of the 2 alternating factors. As gametes contain only one factor for the character, this law is also called as law of purity of gametes, because the gametes are also pure, having only one factor, not both. There is no mixed genes present in the gametes. This is what's called law of segregation, separation of the, that is the factors in the heterozygous individual entering separately into the gametes so that the gamete is pure, receiving any one of these 2 factors. This is also based on the monohybrid class. Now going to law of independent assortment. I mentioned already, the factors are present in different chromosomes. The factors are present in different chromosomes. We have capital R, the small r in a hybrid F1 dihybrid. if you are taking F1 dihybrid, we have the plant round shaped seed with what is called yellow cotyledon. This is the genotype. This is the individual. So genes are present on different chromosomes. So here we are taking the inheritance of two pairs of characters. So in the inheritance of more than one pair of characters, the gene for each pair of character are sought out independently of one another. For example, I mentioned already this R may combine with this one. So we are getting what's called RY, capital RY, two dominant genes, or it may combine with what is called another one, just a mistake. This is what we call a mistake here, small y. Okay, so it may combine with this one, so we are getting this one. So this is because of what we call the presence of gene on different chromosomes. So they are sought independently. The meaning for that one, they are being distributed independently of one another because the factors remain independent. This factor capital R may combine with what is the factor capital Y or small y. So we are getting this one. This is the way we are getting this small r may combine with capital Y to get what is called this combination, or may also combine with what is called small y. So we are getting this combination. So because of the independent assortment only, we are getting four different types of gametes. So it is happening in the inheritance of more than two pairs of characters or more than one pair of characters, will say. So the gene for each pair of character are sought out independently. The meaning for that one, distributed independently of one another. But this law of independent assortment is not universal. So this is based on what's called diagonal cross. The law of independent assortment is not universal. What's the meaning for that one? Not universal. So it is possible, the law of independent assortment is possible only when the genes are present in different chromosomes. When the genes are present in the same chromosomes, the law of independent assortment is possible. You will get the four different types of gametes because of crossing over. So this happens only in some plants, the law of independent assortment, in some animals, but not in all animals, not in all what's called the plants and the inheritance of different characters. So that's why I say it's not universal. It is possible only when the genes are present in different chromosomes. Then only they are distributed independently of one another. So this is the conclusion for that one. That is law of independent assortment. Thank you.